Student, actually our second chapter started from this heading, that is what? Bohr's model of atom. Earlier two videos, some very information about an atom was given, that was about the discovery of cathode rays, the discovery of anode rays, getting, then the Thomson model of atom, then the Rutherford model of atom. This is because the Bohr's model of atom depends on the previous concept. Therefore, I revised it. You have to prepare notes also for it. Okay. Some more informations were given about the Thomson's experiment to find charge by mass ratio. It is very important. You must know these values. Millikan's oil drop experiment to find the charge, so that we were able to find the mass of electron, because directly it was not possible that the electron and proton can be weighed properly, because there were no such apparatus which can weigh the mass of electron or proton. Getting, therefore the earlier two video, these are also very very important. Now student, we are starting our chapter from the Bohr's model of atom. Student, actually the Bohr's model of atom, here the heading is although given about the Bohr's model of atom, but we are not going to study the Bohr's model of atom today, that is in this video. I am not giving any of the information about the Bohr's model of atom. The Bohr's model of atom is given in 1913, and in 1911 the Rutherford model of atom were given. So what happened in this between these the gap year, actually Bohr studied many scientific advancement which were takes place that time. Getting, like many technology were developed, many concept about an atom was given by the different scientists. So the Bohr collected all these development, all this scientific advancement, okay, and then he, after getting their observations, their postulates, then he concluded, and then he gave his theory. Therefore we will study the Bohr's model of theory after the two video or two period. This time we are not going to study for Bohr's model of atom, but we are dealing here how the development takes place, to which Bohr were able to give his suggestion about the atom and model. What were that development? Actually student, electromagnetic theory that was put forward by Maxwell, okay, in 1864. He took help of electromagnetic theory. This theory shows the wave nature of radiation. Okay, what is the radiation? Getting, some important postulates by the Maxwell given for electromagnetic wave theory was the first one, and the written work is given so that you can prepare your proper notes. Okay, therefore already I have written here. The first postulate is the energy is emitted from any of the source. Okay, that source may be like here the glowing bulb, or tube light, or sun, okay, or even the iron rod. When the electricity is passed through the iron rod, it becomes red hot. So that time they are emitting what? Radiation. This is called the emitted radiation or energy. The energy is emitted from any source like filament of bulb or heated iron rod is continuously, that is the radiation, they are not releasing dropwise, but they are releasing what? Continuously in the form of radiations. Okay, and these radiations are called what? Radiant energy. The second postulate given by him is the radiation consists of electric and magnetic field. Look at here in the diagram, you can see here, this is a source, this is the source of light or radiation. So how the light is traveling? The light is traveling in this path. Look at here, and when they travels, the energy when they travels, it travels in perpendicular. Okay, and this is perpendicular to the direction of propagation, and also they generate two type of field, say electric field which is also perpendicular, and the magnetic field which is also perpendicular, and they also perpendicular to each other. So this shows the propagation of radiation. The radiation consists of electric and magnetic field. This is the electric field and this is the magnetic field. Oscillating perpendicular to each other. Look at here, its oscillation is shown here. Perpendicular to each other and both perpendicular to the direction of the propagation. The third very important thing is the radiation possesses wave nature. Here the nature of the radiation is given. This is what wave nature, like it is moving what continuously. Wave nature and travel with the velocity of light. Okay, that is, it is very fast. It travel with very great speed. Great speed. Can you imagine about 3 into 10 to the power 8 meter per second? That is, you can say 3 lakhs kilometer per second. Kilometer per second. That is, in 1 second it can travel 3 lakh kilometer. Are you getting? Sun is 15 kilometer far from us. 15 crore kilometer far from us. The distance of sun and earth is 15 crore kilometer, and therefore it took approx 11 seconds because it travels with great speed. Getting? These waves do not require any material medium. Student, you know that to travel any of the thing they require medium. Okay, like the aeroplane is traveled in air. Like the sound require what? Air medium. Like here, if all the doors are closed, then it is not possible that the sound can pass from this room to another room. But with the radiation, they do not require any of the material medium. Getting? That is, they can travel from any of the part, like even from the space it can travel. Between sun and earth there is space, but lights are travel now. Therefore what we are saying, these waves do not require any material medium for propagation. Student, the radiations are of different type. There are large number of radiations come from the sun, but each and every radiation travel with the same speed. Okay, and these radiations are named on the basis of their wavelength and their frequency, which we will deal earlier. Here, when the wave travel, the upper part, that part is known as what? Crest, and the downward part is known as trough. Okay, this is the wave nature. Distance between two successive crest or two successive trough, this is called lambda. This lambda is known as what? Wavelength. Okay, denoted by lambda, and its unit is what? Meter, or say nanometer, or say what? Picometer. So what is the definition of wavelength? Wavelength is when the wave travel, it forms crest, upper part and downward part, trough. So distance between two successive crests is known as wavelength, or trough is also known as what? Wavelength. Second one is frequency. Frequency. Look at here, the wave is traveling from a particular point, say from this point. How many number of waves travel in 1 second? That is, per second, how many number of waves are passed from a fixed point? This is called what? Frequency. It is given by n, or it is called what? No, that side nu. Okay, and its unit is what? Per second, or hertz, or cycle per second. This is called what? Frequency. Getting? Velocity of light or velocity of wave. Velocity of wave, it is given by c, and it is always it is constant value 3 into 10 to the power 8 meter per second. Are you getting? So these are some very important things. The relation between all these things is what? Frequency is equal to c by lambda. Getting? Or you can say lambda is equal to c by nu, or you can say c, that is velocity, is equal to frequency multiplied by lambda. Getting? You can find this relation in the given radiation chart. Here the radiation chart is given. In radiation chart, I used wavelength in upper portion and the frequency in down portion. student, while you refer NCERT book or any reference book, it may be different. Different means frequency could be upper part and the wavelength should be in lower part. So while you refer my notes and notes given in any of the book, you have to concentrate here. Otherwise, it will develop what? Confusion. So student, here the wavelength is given in meter and the frequency is given nu per second. The value 10 into 10 to power minus 16 and 10 to power 24. If you place the value of lambda and nu, like here, lambda and nu. So lambda is, suppose this is 10 to power minus 16 multiplied by nu, its value is 10 to power 24. If you multiply it, the value come near about 10 to power 8. And what is the value 10 to power 8? It is the velocity of light. So this relation also proved by this table. Say 10 to power minus 16, 10 to power minus 24. This is known as cosmos radiation or cosmic radiation. Cosmic rays. This is known as gamma rays. Gamma rays. This is known as X-rays. Student, all these rays have same velocity, only they differ by what? Frequency and wavelength. Getting? Now this is known as ultraviolet region. This is known as visible region. Look at here. This is the visible region. It started from 400 nanometer to 750 nanometer. This is called the wavelength of visible region. That is, the wavelength is 10 to power minus 6 and the frequency is 10 to power 14. Then come here, it comes what? Infrared radiation. Infrared radiations. Then here it comes microwave. And here it comes what? Radio wave. So these are differ only by the wavelength and frequency, but their velocity always remains constant. Getting? Visible radiation, it consists of 7 type of important radiation. This is called what? Wave-Guer. Okay? And it started from 400 to 750 nanometer. Here I am giving with value with the nanometer. That's